Okay, college algebra students, here we go. So what we're going to do here will feel a lot like review. Hopefully it feels like review, and maybe you'll learn something a little new. Maybe you'll have something reinforced, whatever the case might be. But what we're going to do is we're going to continue our graphing, but we're going to, in this section 2.2, we're going to exclusively concentrate on graphing lines. And the first thing I want to mention is that my assumption is that you guys know how to calculate slope and you know how to use slope to graph. So if you don't understand how to do that, pay attention. You're going to kind of get it by default. If you do, great, you're ready to go. And what I'm going to concentrate on are basically the fact that there are three linear equation forms that we can use. So we'll talk about those. There's one that's very famous that students tend to really like, but the other two, you should be aware of them and know that they're there because they're there to build more math and do more things, and actually sometimes they're easier to use, believe it or not. So what you're looking at are three equations: 2x minus 3y equals 9, y equals 2/3 x minus 3, and then y minus 1 equals 2/3 x minus 6. These are basically examples of the three types of linear equation forms that we have. The first one, we generally call this the general form. All right, it's typically written as ax plus by equals c. So for this example, a is 2, b is -3, and c is 9. What's nice about the general form is the fact that I can represent a line without having to use any fractions. And so back in the day when there were typewriters, if you would, nowadays we have some nice software that handles fractions just fine. But back in my day, it was very hard, right? I'm going to age myself here, to write a fraction on a typewriter. So the best way to actually write a line in a paper or in a book was to actually put it in general form, because your A, B's, and C's are usually integers, and we can go from there. Of course, we'll talk about how to plot from that. The next one is the very famous one. This one is called the slope-intercept form. This is the one that students love. All right, this is the sexy one. Y equals mx plus b. Right, it just rolls off your tongue, right? Oh, sexy. Okay, so, but at any rate, right? So very, very famous form. What it's giving us, if you take a look and kind of compare, right? The number right in front of the x is your slope. So that's telling us how to move. And then the intercept, we're actually talking about the y-intercept here. You can see that if I let x equal to 0, right, which is the intercept, the b, right, tells us where we are crossing. So it's a y-intercept there. So very, very informative, because now, right, this is why we love this, right? Not just because it sounds sexy, but graphing is easy, right? I have a point and I have a slope, and I can just go to town. We'll do that in a moment. But I just wanted you to recognize what we can gather out of it. So the general form, and then the slope-intercept form, which is really nice and useful. Now the last one, right? Oh, by the way, too, notice that the name itself tells you what we can gather from it, right? A slope and in this case an intercept, a y-intercept. Now the next one I kind of unfortunately call the ugly duckling. This is the one that people hate because it looks so complicated. This one is called the point slope form. And as the name suggests, this form, if you know where to look, is telling you what your point is and is telling you what your slope is. Just like this guy here, right? It's telling me what my slope is and it's giving me a point. Now, here's where there's a big difference. Here, it has to be the y-intercept. In the point slope form, it could be any point, as you will see later on in this video. But for now, right, this form looks like y minus y1 equals mx minus x1. So there's what it looks like in formula form. And you can already get to see eyes glazing over. The y and the x, right, remember, that's my solution pair. X and y is my ordered pair solution. Y and x, right, are my ordered pair. Y and x are my ordered pair. So we're talking about here, if you kind of compare and contrast, again, I'm telling you that the slope, right, is sitting right in front of the parentheses around x. So my slope is 2/3. The point we're looking for is a little tougher. Every point has an x coordinate and a y coordinate. So let's do x first. right? Notice in the formula, I want x minus a number. So what I have in here, I have x minus a number. So x1 is the number we're subtracting from x. Of course, what are we subtracting from x here? We're subtracting 6. So 6, right, is basically my coordinate pair. What about y1, right? What's the y coordinate of the point that's given? Same thing. Formula-wise, I want y minus y1. I have y minus 1. So y1 is the number that's being subtracted from y. So looking at this little formula here, what's being subtracted from y? The number 1. So just like the point-slope form, just like the slope-intercept form, the point-slope form gives us very, very informative data. It tells me the slope, so how to move, and it gives me a place to start. Just like this one. All right, maybe a little bit harder, but it does the same exact thing that this one does here. Okay, so now that we know what the forms are and what they look like and how to gather information from them, how do we graph each one? Okay, so for this one, you got two choices. You can either point plot like we did in the past, or you basically change to y equals mx plus b. All right, using some algebra. So I'm going to do that in a moment. Okay, again, we're point plotting. I've made you guys torture for the last couple of modules. Yeah, we're just going to take advantage of. Let's just change that to a more useful form. So let's talk about the other two. So the other two, what we have here, right, is the way we graph is we start at the point that's given. So we're given a y-intercept of 0, negative 3. Right? And then the movement tells us, the slope tells us to go up 2 and over 3. And now I have another data point, 4, negative 1. Really easy, 3. Screwed that up. 3, negative 1. So there's another solution point. We can keep going in this route. We're up 2 and over 3. So another data point, 6, 1. We could also go back, right? We can go down 2 and to the left 3. So there's another data point, negative 3. I think that would be negative 5. So that's what's so nice about that. We know to graph, I need to find the solution points, and by using a place to start and by using a slope, right, I have pretty much generated my graph. So there's a picture of all the solutions. So no wonder why everybody loves that, right? Pretty cool. So what about the other one? Well, again, when you know what you look for and you grab the information out, you do the same thing. This is telling us to start at 6, 1. 1, 2, 3, 4, 5, 6, and 1. So there's 6, 1. And then the slope's telling us to go up 2, 1, 2, and then over 3. Uh-oh, I'm off the board. So how about I go down 2 and back 3. Down 2 and back 3. Down 2 and back 3. And lo and behold, what did I generate? These, right, are basically the same. So my point here, right, is that there's 3 linear equation forms. They all pretty much do the same thing, right? All the solution points of this guy represent all the solution points of this guy. So that means these two forms are equivalent, all right? And then last but not least, I know we didn't point plot this one, but if we took 2x minus 3y equals 9, and we started solving for y, look what happens. All right, so subtract 2 first. Divide everybody by negative 3. We get y. Negative divided by a negative is 2/3 x. A positive divided by a negative is minus 3. And lo and behold, we're right back over here. So the moral of the story is that, obviously we just graphed that. So lots of things going on here. Number one, to graph a line, all I need is a point and a slope. You give me those two things, whether via the slope-intercept form or whether through the point-slope form. I plot the point, move the way the slope tells me to do. Plot the point, move the way the slope tells me to do. So that's one part of this lesson. Second thing is there's actually 3 ways, right, to represent the line of to represent a graph of a line, right? So 3 different line equation forms, and you can use any one of these 3 to talk about the same solution set. So this equation has this solution set. This equation has that solution set, and this equation has this solution set. And that makes things very challenging because when we are going to be finding equations of lines, which one do we want? Because all 3 of them do the same thing. And we'll investigate that in another video down the track. Right now, what we're going to do, now that we know the line forms, how to gather information, what we're going to do is just go do some point plotting. All right? We're already 10 minutes into this. I'm going to stop this one, and we'll do our graphing in the next video.